All right, in the next two problems, we're going to be looking at doing multiplication of fractions. And recall multiplying fractions, what you really do is you take the two numerators, you multiply those, and you get the new numerator. And then you take the two denominators, multiply those together to get your new denominator. However, if there's any numerator, either one of these numerators cancel with any of those denominators, you'd want to do that because it'll make your final multiplication step much easier for you. And so let's go ahead and let's do number 6. You will notice that this process here of multiplying fractions is very similar to this simplifying fractions. You basically just need to factor everything and then cancel and then write what's left. Okay? So let's go ahead and try that. In this problem, number 6, we're going to need to factor, 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 factor. Anything that can factor needs to get factored. So I'm going to go ahead and set up my problem here, and I'm going to start, remember, greatest common factor first. So we've got a 2 and a 4 has a common factor of 2. I don't see an x in both and I don't see a y in both, so it looks like we can only take out a 2, which is going to leave you with something plus something. We'll take a 2 out of an x, you're left with an x. Take a 2 out of a 4y and you're left with 2y. In the denominator there, looks like we just have a 10x. There's no addition or subtraction in that problem, so therefore we will not be able to factor, because if you only have one term, you cannot do any factoring. In the second numerator there, we've got a 15x squared. Again, no adding or subtracting in this numerator, so that term is also already factored. So we'll just rewrite that. And then for the final denominator, looks like we have a 1 in front of the x, so we're going to have no common factor for the 1 and the 2. And as far as the variables go, none of them are repeated in either of the terms, so it looks like that is also already factored. So at this point in time, and since this is added and subtracted, actually let's go ahead and put this in parentheses. So we're ready to start canceling, and I like to just start canceling on the top left and work across the numerators, and after I've worked all the way across, canceling whatever I can, at the end I'll be able to then just write my final simplified fraction. So what I'm looking for now is anything that can cancel with a 2, and that factor would, in order to cancel something with a 2, you can't have the factor of 2 attached to anything using adding and subtracting. So if you see we have a 2 here, but this 2 is attached to this x by addition, so we're not going to be able to cancel the 2 there. But you will notice the 10 is multiplied by this x, so since this is just multiplication, we have factors, because factors are things that are multiplied. So here that means this 2 can cancel with this 10x, which will leave you with a 5x. And then you'll notice we have a x plus 2y in the numerator and an x plus 2y in the denominator. Those entire sets of parentheses can cancel because they're 100% the same. So both terms in the numerator here are gone. So let's move over to this numerator. We've got a 15x squared. Well, the only thing we have left in the denominator is a 5x. Well, a 5 could cancel with a 15, and this x could cancel with that x squared. So it looks like this is going to cancel with this term here. 5 into 15 goes 3 times. X into x squared leaves us with an x. And apparently everything in this problem is gone with the exception of 3x, which is in the numerator. So our final answer here is just 3x. Okay. On problem number 7, this is an Algebra 2 student's nightmare. Look at all this factoring. We got factor, 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 factor. We have quite a few terms here need to be factored. So let's first check to see if we have any greatest common factors. It doesn't appear so. Looks like none of the terms have x's all the way through, and all of them start off with a 1 for the leading coefficient there. So there's no common factors for any of those. And since there's 3 terms, this is going to be opposite of FOIL for all of these. So I'm going to go ahead and throw in all my parentheses on the problems here. And let's just start doing them one at a time. Looks like in the first one, Again, we're going to have x and x for our first term because it's just x squared, so x times x is going to get you the x squared. So now we're looking for factors of 4. So we need numbers that multiply together to get you 4, but then add together to get you a -5. Okay, so looks like we're going to have -4 and -1 because -4 times -1 is +4, and -4 added to -1 gets you the -5. In the denominator, again, the first term's x squared, so we're going to know we're just going to have an x and an x there. So now we need factors of 28 that gets you 3. Okay, so we start looking at the factors. So let me help you out on this one. We're going to start listing them out. 1 times 28, 2 times 14, 7 times 4. And because we're looking for two numbers that multiply together to get you -28, we know one of the terms is going to have to be positive, one of the terms is going to have to be negative. And if that were to happen, we'd be subtracting these two numbers in order to get this 3x there. So which of these, if you subtract together, do you get a 3? Looks like the 4 and the 7. Okay, so we know we're going to have a 4 and a 7 here, and we need to get a +3 at the end. So it looks like the 7 is going to have to be positive and the 4 is going to have to be negative in order for us to end up with a +3, because +7 and a -4 gets you a +3. Okay, so then we have to factor the the second fraction, the numerator and the denominator. So again, looks like we start with an x and an x, and then we need factors of 3. Not many options there, just 1 and a 3. Now we just need to make sure we get the signs right. Because these two have to multiply together to get a negative, we know the signs have to be opposite. So one positive, one negative, and since we end up with a +2, looks like the larger number there is going to have to be positive. Okay. Then in the denominator, again, it looks like we have an x and an x, and we need factors of 21 to add up to 10. So our options would be 1 and 21 or 3 and 7. And it appears that the 3 and 7 will add up to 10. So it looks like we're going to use the 3 and the 7. And since both signs are positive, both of these need to be positive as well. So we've got that all factored, and now at this point it's just a matter of going ahead and canceling common factors. So I'm going to start at the left and work across. Is there an x minus 4 on the bottom? Yes, there sure is. We can cancel that. Remember, you only do 1 from the top with 1 from the bottom. Is there an x minus 1 on the bottom? In this case, it does not appear so. We do have an x minus 1 on the top, but you can't cancel a numerator with a numerator. So neither of these are going to be able to cancel with the bottom, but we do have an x plus 3 on the top, which can cancel with an x plus 3 on the bottom. And now we're at the very end here. It's just a matter of writing our final answer. So it looks like we have an x minus 1 on the top, and there's actually 2 of them there, so we can just go ahead and write that as x minus 1 squared. And on the bottom, looks like we have 2 of the same factors there as well. You have an x plus 7 and another x plus 7, so we can write that as x plus 7 squared. And that is our final solution.